Hello and welcome to our Metal webinar series. This series of apprenticeship-focused webinars is developed in partnership with the Composites Institute, or IACMI. I'm Melissa McGregor. I'm a director here at Jobs for the Future, and today we're thrilled to have guests from the ARM Institute join us to talk about AI competencies in metal manufacturing apprenticeships. Next slide, Kate. This is our agenda for today, and Becky Caldwell is going to give you an overview of the Metal project. Then I'm going to talk a little bit about JFF's Center for Apprenticeships and Work-Based Learning. And then I'm going to introduce you to Emma Miguel from the ARM Institute, which is the Advanced Robotics for Manufacturing Innovation Institute. ARM is a national public-private partnership driving innovation in robotics, automation, and workforce development. Then I'm going to turn it over to my colleague, Becky Caldwell, who will share about funding we have available for employers who are adopting the apprenticeship model. And with that, and on to the next slide, I'll introduce you to my colleague, Becky Caldwell. Becky.
Hey, welcome everybody. Thank you for joining us for this webinar. If you guys have any questions, please put them in the chat. We can answer them as we go along or answer them at the end. We'd love to hear from you all, and just your observations about what you're seeing in the field would be great too, because it's definitely a new topic for us, and we're all learning about it. So we'd love to hear what you guys have to say about this topic. We're really excited to meet the people from ARM and talk about this topic because there's so much interest in it. But my job here is to talk about metal in general, the project in general. It's a really big project involving a lot of different partners. And we're Jobs for the Future, and we're just one of many partners on this project. We wanted to give you guys an overview of all the resources that are out there because of this project and through this project. So next slide. As Melissa said, the METAL project, which stands for Metallurgical Engineering Trades Apprenticeship and Learning, is a national initiative led by the Composites Institute, IACMI, the Composite Institute, which is one of the country's manufacturing institutes. If you're unfamiliar with the institute, go online and read about it because they do a lot of great work in a lot of different areas. And they'd love to hear from you. So check out their website to learn more about the Composite Institute. And their work on this project is supported by the Department of Defense, the Industrial Base Analysis and Sustainment Program, which is under the Office of Industrial Policy. And it got started a couple years ago with some founding partners, and we always like to mention them. And the founding partners were Penn State and University of Tennessee. And since then, many other partners have joined, including Jobs for the Future, as well as several other universities around the country. So all offering different resources to support this project. So next. We wanted to talk a little bit about why metal is important. A lot of you are on the call already understand the importance of casting and forging, but it's a critical part of the supply chain for manufacturing in our country and really critical to the nation's defense, which is why the Department of Defense identified casting and forging as a priority and went to the Composite Institute, worked with them to develop this project. So it's a part of we can't live without them. The supply chain will fall apart without them. And it's very important to security. And it's also, but to help build that, we really need to help build the workforce. There's just not enough people out there doing this kind of work. It's a problem across manufacturing. But the estimates are that by 2028, the U.S. casting and forging industry will need 122,000 additional skilled professionals, including tradespeople, engineers, and other critical roles. Next. As I mentioned, our part of the project is the work-based learning portion of the project. That's what we focus on, but metal is a lot bigger than that, and there's a lot of ways you can plug into this project and support this project and draw from this project. And it really starts with the metal team, starts with doing K-12 outreach, doing workshops to interest young kids in STEM and in casting and forging, going on to engage them with boot camps at the universities, and then all the way up to educating our workforce about casting processes and metal, and then to the employee, which is helping upskill existing workers and train new people to enter the industry. And one of the main things that they offer as part of this project are these boot camps, which are at the universities, which are free 4 to 5 day experiences on university campuses where people get experience pouring metal. And all of the boot camps are listed on IACMI's website under events, and you can look for them. The other big thing they offer that anyone can take advantage of is this free online training in casting and forging. It's really hard to find online training for these subjects. The associations offer a lot of great training. And so this is just some supplementary, complementary training that's available on the IACMI's website. So go there and go under training and sign up for their courses. So next. I'm going to turn it back over to you, Melissa.
Great. Okay. Thank you so much, Becky, managing the stage. So if you're not familiar with Jobs for the Future, we're a national nonprofit that sits at the intersection of learning and working. And our mission is to transform the U.S. education and workforce systems to drive economic success for people, businesses, and communities. Next slide. So at JFF, we're focused on building the human infrastructure that powers innovation. So connecting all of these pieces, technology, training, and people. And as robotics and AI changes the roles of workers in manufacturing and other industries, our role is to make sure that workers have real pathways, like apprenticeships, to grow with that change. We're helping manufacturers build the skilled, adaptable workforce they need while improving job quality for that workforce. And you'll see here a diagram of advanced manufacturing, apprenticeships and work-based learning, and AI and emerging technologies. And JFF really tries to connect these dots. So manufacturing is a priority industry for both JFF as well as the United States. We support the growth of this sector through workforce development initiatives like apprenticeships. Apprenticeships and work-based learning are long-term strategic solutions that build talent. And apprenticeships are specific to occupation. So for example, you can't build an apprenticeship in manufacturing as a whole or in AI as a whole. You build an apprenticeship around the competencies that are required for a specific occupation. And then over time, apprentices gain proficiencies against a set of competencies for that occupation. And for more and more occupations, AI skills are becoming required for those roles. And JFF is helping the workforce to adapt to new tools like AI by supporting employers and group sponsors, other group sponsors of registered apprenticeship programs to embed those competencies into apprenticeship programs. So now it is my pleasure to introduce you to ARM and how they're doing this work through a new framework for AI competencies in manufacturing. Next slide. Oh, sorry. Thank you. So Emma and Miguel, will you introduce yourselves?
Yes, hi, my name is Emma Yord. I'm the Senior Education and Workforce Development Partnerships Manager at the ARM Institute. So my primary role at the ARM Institute is to manage our local, regional, and national education and workforce development partnerships with workforce investment boards, community colleges, and four-year colleges who are all focused on helping to advance our advanced manufacturing and AI workforce.
Good afternoon, everyone. My name is Miguel Rodriguez. I'm a senior program manager for the ARM Institute on the technology programs side of things. So I manage a lot of technology development projects for the ARM Institute. I've been around for about 3 years now, and I help with everything, starting with the process of selecting projects to the execution of the projects, the competition, their final demonstrations, and yeah, I'm happy to be here.
Thank you. Emma?
Take it away. Great. Next slide, please. So as Melissa mentioned in the introduction, the ARM Institute is one of 18 manufacturing innovation institutes across the country, and we are part of a federal investment to bring manufacturing back to the United States by investing in a variety of manufacturing processes. So you've already heard of IACMI and the ARM Institute, but there are 16 other institutes focused on different parts of the manufacturing process and different types of manufacturing. Our mission at the ARM Institute is to accelerate the development and adoption of innovative robotics technologies to help advance our nation's advanced manufacturing. We leverage a robust consortium of about 400 partners across industry, academia, and government to do 4 primary things: make robotics, autonomy, and artificial intelligence more accessible and cost-effective for U.S. manufacturers, both large and small; train and empower the manufacturing workforce. We know that we're going to have a massive advanced manufacturing workforce shortage in the next decade, so that's a critical part of making sure that we're able to implement these technologies. Strengthen our economy and our global competitiveness, and elevate our nation's national security and resilience. And today, Miguel and I are going to be focusing on those first 2 pillars of our mission. So he'll be talking a lot about the technology investments, as he mentioned, and I'll be speaking about how we're investing in our nation's workforce. Next slide, please. So a key thing that the ARM Institute has done as part of our workforce development initiatives over the last 8 years is to build our robotics competency framework. We undertook this work in 2019 with stakeholders from across our consortium that I mentioned, and they came together over a series of 3 days at our offices in Pittsburgh, Pennsylvania, to identify what are the most in-demand and critical competencies that an advanced manufacturing worker is going to need over the next decade in order to be employable in this sector. And further, what do those skills look like across a career pathway? So in other words, what skills might a worker need as an entry-level person first coming into the industry? And as they move up the ladder, what are the types of skills that they're going to need to invest in order to reach higher levels and attain higher salaries? So this framework you want to read from the bottom up. We've built it as a pyramid or a ladder, if you will. At the bottom, you'll have the robotics technician, and this is what we define as our entry-level advanced manufacturing role. This might be a person who's completed a 2-year apprenticeship or an apprenticeship program or a 2-year community college degree. They might have a series of stackable credentials that they've accumulated, but we would expect a person at the entry level in an advanced manufacturing role to be able to maintain and troubleshoot a manufacturing line in a robot, understand what it looks like to program a robot on the manufacturing line. And as they move up into the robotic specialist and the robotics integrator roles, we really would want to see them getting more applied hands-on knowledge in the sector. And then on the right-hand side of the slide, you'll see the essential soft skills. So we know that technology skills are critical, obviously, to implementing these technologies, but we also want to make sure that we're not losing sight of the essential soft skills, such as teamwork, critical thinking, problem solving is a huge one when you're working with robots, because while they can do tasks much more efficiently and much more quickly than humans do, they are also prone to programming error. And you need to be able to identify what's going on in the manufacturing line and identify that problem quickly so that you're not losing a lot of downtime. Next slide, please. And here's another visual of our Industry 4.0 or Advanced Manufacturing Robotics Career Pathways, starting from the left-hand side with the robotics technician. This gives you a little bit more of a job description for what we would expect a person in each of these roles to be doing. And you can find more information about both the competencies and the jobs themselves on our website, roboticscareer.org, that we've built to house both the competency framework, information about these roles, as well as a database of over 17,000 post-secondary programs across the United States that give students at least one, and in many cases, many more than one, of our competencies that we identified on the previous slide. So if you're a student looking to get into advanced manufacturing, or you're an employer looking to hire somebody to fill those manufacturing roles, you can, as a job seeker, both identify future training opportunities for yourself to get senior level skills. And as an employer, we've also added a job board as of last June. So you have the opportunity to post your job and hire people through roboticscareer.org. Next slide, please. So AI-enabled robotics transforming the manufacturing workforce. I'm sure many people on this call have sat in on at least half a dozen webinars this year on AI alone, whether it's applied to casting and forging, metals, advanced manufacturing more generally. Everybody's talking about AI. And when as it has become more into the national conversation, we at the ARM Institute really wanted to examine, well, what does it look like to incorporate artificial intelligence into an advanced manufacturing line? And what does it look like really? And what does it mean for us to have artificial intelligence on the manufacturing line? And what skills do workers need to think about? And we see a lot of key workforce changes as we do across the industry or across the nation when it comes to AI. We're looking at shifting skill demands for employees. There are new roles emerging, or existing roles are taking on additional responsibilities now that workers are being expected to interact with artificial intelligence on a regular basis. There's an upskilling and reskilling imperative, both on the side of the worker to keep their skills competitive and current, because we know that this field is changing rapidly, and on the side of the employer. And that's really a critical piece that we at the ARM Institute try to focus on, is that the onus is not just on the worker to upskill themselves, but also on the employer to continue to invest in their employees. And as they implement these new technologies, make sure that their workers have the skills to stay current and stay safe and implement these technologies. There's enhanced safety and productivity, and then a workforce redesign. So anytime, obviously, you're implementing automated or artificial intelligence solutions on your manufacturing line, you need to be rethinking what your manufacturing line looks like, what your workers are going to be doing, and how they're interacting with each component on the manufacturing line. Next slide, please. So similar to the work that we did for our initial robotics competency framework, we pulled together a group of our stakeholders for a multi-day summit back in March of this year. And we sat down and we asked the question, what does it look like for a worker to have competitive skills in artificial intelligence and advanced manufacturing? And if we think about AI as applied to advanced manufacturing, what skills are the workers going to need to stay competitive, and what skills are they going to need to move up the ladder in terms of seniority and pay scale and applied knowledge? So exactly the same as our previous competency framework, you're reading this as if it's stackable from the bottom up. So at the bottom, we have our AI data technician that's doing fundamental AI work. We're talking about data collection, data verification, data labeling, any data that's coming off the manufacturing line. This person is going to be responsible for collecting it, labeling it, figuring out what to do with it, making sure that that data is usable, and then using it to inform future decision making about the line. And then we're working our way up the ladder, talking about an AI implementation specialist who may be doing more model training and test development with large language models. They may be doing data analytics, troubleshooting systems, and then we'll have AI developers where those AI developers are actually developing the models that are informing the way that the manufacturing line works. And the same thing on the side, you'll see our essential soft skills, and you'll see a few things that are different here from the robotics competency framework that I presented earlier. We're talking about healthy skepticism, right? We hear a lot about how AI models are hallucinating or making up information that doesn't exist in the real world. And so in order to work with this data, even if you're just doing it on an advanced manufacturing line, you need to be able to have that skill set as well. Next slide. And same thing here, we've developed our career pathways and included a little bit more information on each of the careers in the AI data technician pathway. And you will soon be able to also find all of this information on roboticscareer.org as we bring and incorporate the AI competency framework into the work that we do on there. Next slide. So what's next? As I mentioned, we're identifying the necessary robotics competencies, understanding robotic career pathways and how AI is applied there. Finding the right training for the pathways is a critical part of what we're doing. So we have an endorsement program where we endorse programs across the country that are in alignment with the competency frameworks that we've developed, currently just in robotics and manufacturing, but soon in AI as well, because we want to make sure that training programs across the country, when they say that they're teaching relevant and important skills, that they actually are doing that at a standard that we feel is nationally applicable. Next slide. So key takeaways takeaways for any employers on the call. The competency frameworks that I presented earlier can be used to anticipate future hiring needs if you're thinking about incorporating advanced manufacturing or artificial intelligence into your manufacturing line. Those competency frameworks can be used to inform job descriptions, inform what professional development you might invest in for your employees to make sure that you can retain really good talent that you have. You can identify skills that employees may need in the future, and then training programs that teach those skills. Focusing on targeted reskilling programs can be a great and cost-efficient way to continue to invest in really specific skills. And we see more of those emerging as stackable credentials, micro certificates. There's lots of buzzwords out there for what that means. And lifelong learning is going to be critical for employees to stay current. And as an employer, what you can do to encourage that is to help invest in their professional development and encourage them to continue to upskill so that you can retain those really good, talented workers that are on your manufacturing line, because we know that hiring and replacing good workers can be expensive. And at this point, I will turn things over to my colleague, to Miguel, who will touch a little bit more on the technological side of everything. Thank you.
Thank you, Emma. Next slide, please. Yeah, good afternoon, everyone. I'm going to take the next couple of minutes to talk about a few of the recent ARM projects that are good use cases of AI in manufacturing. Next slide, please. First of all, I wanted to set the stage for what is AI and how that compares to other common terminology, such as machine learning and deep learning. AI, or artificial intelligence, refers to systems that mimic cognitive functions. It is a broad concept of machines mimicking human intelligence. That's kind of, it's a very broad application right now. Machine learning is a subset of AI, where the machine itself learns from data without any explicit instructions from humans. Hey, when you see this, do this. It's just learning, seeing data, and learning from it. During training, it does rely on patterns from well-structured data, data that's labeled, well organized, to learn and then be able to predict future results. So you always hear that data is very important for training AI systems, and a lot of data is needed for training machine learning algorithms. Deep learning is a subset, it's another tool on the machine learning, where the system can learn from a large amount of unstructured data, and it identifies patterns without having to have any type of manual human intervention. It kind of just requires even more data than machine learning algorithm, and it relies on neural networks and training these neural networks with a lot of data to just start identifying patterns and be able to, with a set of unseen data, be able to predict results from that. Next slide, please. The idea of AI manufacturing has been around for a few years now. It has been used during the design phase of products, where designers are going through several iterations. So to help speed up iterations of some either materials or forming processes, they have used AI to just speed up the design process. It's also being used a lot to identify weak points in supply chains, kind of being able to predict when certain supply chain goods are going to run out and being able to predict when orders need to be placed. So those are some areas where in manufacturing where AI has already been used at enterprise levels. So those are more of business operations. However, we're starting to see AI being used in other type of manufacturing applications like real-time monitoring or process optimization. Something I do want to bring your attention to, it's quality control and inspection. ARM has invested in a lot of projects that tackle inspection in specific, because that's an area where there's already a lot of data available from manual processes. So it's easier to teach some of these AI machine learning algorithms how to use this data to predict results. Next slide, please. Visual surface inspection of components is a manual process that tends to be the bottleneck for a lot of high volume production applications, especially when these components are very critical or are mission critical for a product. There are a lot of benefits with doing manual inspection. Humans are inherently very flexible and can change from inspecting one part to another part relatively quickly. So there's not a lot of setup time with just a human getting up and inspecting a different part. It's also for small batches, for small volumes. It can be very cost effective. Someone that has been trained to inspect a certain type of parts because they're flexible, they can inspect a different type of part if it's a small batch, and a human can do that very quickly. However, manual inspection, it's still very burdensome and it's a tiring process. The results can be subjective. For example, an operator who is got a 9-hour sleep the night before, had their coffee, it's going to have a different rate of finding defects than an operator that stay up watching their favorite football team playing all night before. So that kind of subjectivity can affect the results of these critical parts, something that an automated process may not have that type of subjectivity. The last thing is that for critical applications, these operators take months and months of training to become proficient enough at inspecting these parts. They do a lot of this with other operators who are experts and kind of learn from them. And as a result, scaling up is something that can be difficult for small businesses. If you one day get an order and it's 10x what you normally used to, you won't be able to fulfill that order because one operator, it's not going to be able to handle the throughput. Next slide. So aerospace engine components is a very critical, high volume application. Well, there's also a lot of other challenges involved. There's a lot of complex geometries, high reflectivity for some of these parts make visual inspection very difficult. There's a lot of small features. I will show you soon some examples of this, like defects that they're looking, but it can put a lot of strain on someone looking at these parts with all of these different small features. For example, the engine stator vane that you see on the top right corner, it's made out of polished aluminum, so it's very difficult to find defects on these type of parts. But there's our very high volume parts. The picture on the bottom right corner, it's basically each one of these plastic containers contains anywhere between 50 to 100 parts. So it is a operator's job to actually go through this room full of parts and inspect each one of them, something that for 8 hours a day, 5 days a week, sometimes 2 shifts. So they're meeting the demands of the workload. It's something difficult for some of these aerospace component suppliers. Next slide. These are some examples of what kind of defects these operators are looking for. Even on this picture on the left side, those black spots, those are defects the operators need to be able to catch. Same thing with dents or machining marks. Those are the type of defects that they're looking for. Operators use a combination of visual and tactile to kind of find some of these defects, which once again, doing this for several hours in a day, the operator's subjectivity might come into play and some defects might go unnoticed. Next slide. So the ARM project team, which consisted of University of Washington, they were the prime, University of Connecticut, GK Aerospace, who is the one that manufactures these parts, and Boeing, the end user. They came up with a system that's able to inspect all of these parts using a robotic arm and a high quality camera to take pictures and train a machine learning algorithm to find defects on the surfaces of these parts. So that's what the system is doing here. On the bottom left corner in the picture, this is what the user interface looks like. It's showing you which parts the robot has picked up, and also on the surface on both the front and the back end, which areas of the part have defects, just to flag that to a second inspector. Next slide. The system uses the CAD model of the part to identify several sections on the surface of the part that needs to be photographed and inspected. It will then create the path for the robotic arm to follow that is needed to both pick up the part from the container and then present it to a camera at different orientations, different positions to be able to capture different areas of the part for inspection. Each one of these pictures is then being put through a machine learning algorithm to just check the different areas and classify them as defect-free or no, there's a defect there. Once it does that for the parts, it will decide whether or not the part passes the inspection criteria and either place it on a container where all the parts pass or in a container for the parts that did not pass inspection. This system is able to inspect the part in about 1 minute compared to the 7 minutes it took an operator to manually inspect the part. They also found that the accuracy of the system was higher than operator. Like I said, because of that subjectivity, the average accuracy of a manual operator was around 75 to 80% of the defects will be caught. But this system showed 95% accuracy on detecting defects on the surface. For all of the parts where defects were found, those will get a second round of inspection with a human just to double check and do the last pass before accepting or denying a certain part. Something that the project team discovered is that another benefit of using a robotic system, an automated system, is that you can use very high intensity, very bright light that a human eye could not be exposed to for hours a day. We're talking about like, when you take a flash in a picture, that really bright light. So using really bright light, they were able to find even smaller and smaller defects on the surface, scratches that even the best operator on the best day will miss. This system was able to catch it because they were able to use light, really bright light, which a normal operator wouldn't be able to use on a daily basis. So that was a very eureka moment for the project team. Next slide, please. So the project team had a follow-on project where they integrated this visual inspection technology with another manufacturing process, which has to do with sanding of F-35 canopies. So right now, this is a manual process where, a manual operator will go through different grades of sandpaper and sand the canopies. These are our acrylic plastic canopies. We'll sand the panels, and then after it's done through the whole sanding process, there will be a fighter pilot that will come in and actually do the final inspection. So it's also subjective by the pilot. If they say, no, this is not clear, or no, you miss a scratch, the whole part will need to be put through the whole sanding process to eliminate those scratches, those defects. This system, it's doing both the sanding and inspection at the same time. So in between each of the different sanding stages, before the system moves on to a higher grade paper, the inspection system will check it, and if it finds a scratch or something, it will tell the robotic, the sanding arm, to, hey, you missed a spot here. Still use the same sandpaper, finish it before you move to the next stage. Because if you get to the final inspection and then you find a scratch that is too big for the fine sandpaper to take care of, then you have to redo the whole thing. So this process allows you to go to higher throughput because you're doing the inspection in between each of the sanding phases, which helps the system catch defects earlier, such that the rework it's less instead of waiting until the end and then having to rework the whole part. Next slide, please. Actually, if you go back one slide, one other thing I wanted to mention is that because a fighter pilot is the last person to say yes or nay for a part, the inspection requirements, the transparency criteria, it's not very well documented. It's kind of different pilots may have different criterias. So having an automated system also means that you have data to actually back your inspection, back how the quality of your part. So being able to quantify the part also means that you can be more efficient and have less scrap, because you know that your process is either meeting those requirements or not. So that's another benefit of using an automated system compared to a manual user subjective inspection system. Now we can move on. The last project I wanted to also present here is this project with Capstone Robotics, Ohio State University, Jascabo Robotics, and the Southwest Research Institute, which is looking at grinding and removing the parting line of large casting parts. This project is using machine learning to actually not just decide how the part needs to be grinded, but also identify what is a feature of the part that needs to be part of the part and what is flashing that needs to be removed. The system is also, the machine learning system is also used to figure out the order in which the grinding needs to happen in order to make it the most efficient and take the least cycle time and remove the most material possible. So this is another example of using machine learning algorithms to teach robotic systems to be able to make smarter decisions, the same way that a human learns over time the best way to grind a certain part to remove the flash. That experience can be transferred. An automated system can learn that type of experience and be able to make smarter decisions when it comes to the order operations when grinding. Next slide. So just a last few lessons. So machine learning and deep learning algorithms are actively in use right now for business operations. So once again, that is things like design of new products or keeping an eye on your supply chain to see whenever you're going to have low quantities of something, being able to predict that. So that's where AI, machine learning, and deep learning is being used right now. As I mentioned, high quality data is very important, and a lot of it, especially data that's useful, it's well organized, it's well labeled. That's very important. And all of these machine learning algorithms and processes, they're slowly making their way to the production floor. ARM has invested in a lot of projects where we're moving the TRL needle from 4 to 7 and getting it closer to that production-ready system that can be more easily deployed to larger and more manufacturing floors. Next slide. The last thing I wanted to mention was that all of the projects that I went over today, they were part of our standard request for proposals process, what we normally call project calls. So we have 3 active project calls going on right now. One of them is with the Maritime Industrial Base. So those are 9-month-long projects looking for a more production-ready turnkey solution to just some of the problems that the Maritime Industrial Base is facing. We also have another project called sponsored by the Air Force that's looking to do open die incremental forging using robotics. So that's a longer development project. It's a lower TRL. It's a 4.5-year period performance, and we're looking to spend about $5.6 million in federal funds for this development, and submissions are due in early December. The last project call we have active right now, it's what we call our core technology project call. So we have this one about once a year. It's a year-long period performance, about $500,000 in federal funds with a $500,000 cost share requirement. So that one, the 2601, we're looking to start accepting submissions in February of next year. All of these project calls, you have to be ARM member to actually be able to make submissions. So if you want to learn more about either the project calls or how to become an ARM member, please reach out to membership or arminstitute.org, or either to Emma or myself, and we'll be happy to help you. Next slide. That's the end of my presentation. I think we will now hand this off to Melissa.
Thank you so much, Miguel, and also Emma. I've learned so much just in the past few minutes as well. it's super helpful for me personally to see some real life examples of what we're talking about when we say AI in manufacturing, and so the case studies were really helpful. We have some time now for questions, so if anybody has any questions, feel free to drop them in the chat. I'm not sure if people can come off of mute and ask their question. Maybe somebody can give that a try, and if otherwise, please drop your questions in the chat. We have some experts here to help to answer all your questions today.
Well, this is Becky. I have a question for you all, maybe for Emma, but how, if a company wants to start upskilling their current workers about AI, where do they start?
Yeah, that's a great question. And that's a tough question to answer right now because unfortunately the landscape of both AI as it's implemented in the workspace as well as AI education is constantly changing. And so there's not a ton of like post-secondary 2 and 4-year degrees on artificial intelligence right now. There are some like stackable micro credentials that you can find. I took a course on artificial intelligence for people who are not technologically inclined through Coursera, which was helpful. But probably what a lot of employers are looking at is trying to identify the skills they want their employees to have, and our competency framework can certainly help with that. And then looking at some sort of bespoke option through a curriculum developer or maybe your local community college who might be willing to partner with you on developing a curriculum that meets your needs. It's changing a lot right now. Hopefully in a year or two, we'll see some other schools really responding to the need, but the landscape right now is very new.
Great. And Crystal said, is CNC machining an occupation that falls under AI manufacturing umbrella, or is it only robotics?
Great question. I think that one's directed towards me. I'll do my best to answer it. And if I don't, Crystal, let us know. Miguel can tackle it. We would consider that under the advanced manufacturing kind of umbrella, because we have a lot of robots that are still going to do that type of work. But the people are being removed from it. So we would consider all of that part of still advanced manufacturing. Advanced manufacturing just usually means there's one or more robots somewhere on your manufacturing line. And a lot of CNC machining now also is something that employees are able to program and walk away from, or at least supervise, and it's not something that they're doing hands-on. So there are automated solutions to CNC machining that exist out there.
And with those kind of solutions, then you'll have data AI could be part of other things other than robotics, right? Because I think that's what the question is too. They don't have
Absolutely.
to have robots to be interested in this topic and incorporate it, right?
Absolutely, yeah.
Another use of AI for CNC machining or just general manufacturing as a whole is, yes, your point, be able to gather the data and do predictive maintenance. When is your machine, like take that data, when is your machine going to go down so it doesn't hurt your production? Being able to use AI and that data to feed algorithms that can predict that more effectively. So, you can plan better on your production lines. And hey, we know that this machine is getting to that point. Do we need to take it down now, or no, the data shows that we're still good, we can keep production, we need to slow down for that?
Right.
I have a question that's kind of a follow-up to Becky's question about where do you start? And I noticed on the AI competency framework that several of the different competencies had to do with data. So data hasn't necessarily previously been sort of a manufacturing task or a competency. Would you say that that you're seeing a trend or a shift in that? And how do you classify data or data analysis? Is it something that you think that the actual manufacturing technicians need in their skill set, like an essential skill, or is that something that you have to hire for or train for?
Yeah. Miguel, do you want to maybe take a stab at that from the tech side, or?
Yeah, no, absolutely. I will say that the important thing with data, I think that a lot of manufacturers for a while have been data logging, just, kind of recording all sorts of data that comes out of CNC machines, any type of injection molded machines, any type of that. There's been a lot of a practice for just logging data that has been done for a while, but useful, effective data, it's what AI needs. If you have data that's not very well organized or it's just very random, and there's all sorts of things that it's very important. Are they being recorded at the same rate? Are they coming from different sources? Are they, the same level of accuracy? So all of that information, having that structure is very important. And being able to, on the human side, be able to look at this data and kind of provide some context for the machine to be able to learn, okay, this type of data means this context. There's still human input that it's needed for the to make sense of the data for the algorithms. So that's what the shift it's kind of going towards. It's not just we need all data. We need good quality data, and being able to have people that can identify that and be able to create those type of standards or make sure that everything on their production floor kind of follows the same guide rails to make it easier for an algorithm to use in the future. Understand what those requirements are and making sure their machines are meeting those data requirements.
Thank you for that. In the chat, Tanisha also, and I hope I'm pronouncing your name correctly, says, what advice would you give to state workforce organizations aiming to help displaced workers find pathways into this work?
Yeah, that's a great question. I would advise state workforce organizations to do a few things. One is if you are not already in contact with your state manufacturing extension partnership, that's a great resource. Unfortunately, due to federal level budget cuts, a lot of manufacturing extension partnerships are either cutting their work or are shuttering altogether in the next year or two. Which is unfortunate because they provide amazing resources to workforce and manufacturers across the country. So definitely reach out to your local MEP sooner rather than later. If you Google it, I know that there's a map on the Department of Commerce site that they were funded by that has all of the MEPs for the country. And if you're in a bigger state like Texas or Pennsylvania or California, there's usually a few regional ones. Smaller states will have just one statewide MEP. And they'll be able to probably connect you to apprenticeships, which are, we talked about that earlier. Melissa talked about apprenticeships. Those are a great way to get folks into this. Another way would be to look at some of the upcoming federal grants that may be coming out. The new federal administration has released America's Talent Strategy, which is their strategy for the U.S. Workforce. If you're a state workforce organization, you may already be tracking that, but that indicates that the administration at some point in the future, I know that the federal government is closed right now, but at some point in the future, they may be anticipating releasing additional funds to put folks into these jobs. So that is something to be tracking as well. And you can also always reach out to the ARM Institute, even though we're based in Pittsburgh, Pennsylvania. As I mentioned at the beginning of the call, we are a federally funded national organization, and we may be able to help connect you to local colleges or training opportunities in your area if you're looking in a specific region, and connect you to folks that way to help people get into that pathway.
Thank you. Also in the chat, Tracy said, for clarification, are the robotics careers that you mentioned in today's webinar, are they national occupational frameworks currently approved by US DOL Office of Apprenticeship? That might be a question for me, but go ahead, Emma or Miguel.
They are not currently approved, and thank you for interpreting that acronym. I was reading it, trying to figure out, I assumed it was the Department of Labor. They are not currently. That's something that we hope to do in the future, but no, currently they are not.
I think a lot of sponsors are currently trying to find ways to embed the competencies for AI into their apprenticeship pathways. John asked, how much CS? And that's an acronym that I don't know.
I think it's computer science.
Computer science is necessary for robotic technicians. What characteristics do the most successful robotic technicians display?
Yeah, that's a great question. We have not identified that computer science is a critical skill for robotics technicians to have, at least in the programs that we've looked at and the folks that we've talked to. I have run a robot or a cobot, excuse me, on a manufacturing floor, and I have zero computer science or robotics background. I have a background in economics and urban planning and economic development. So I don't have any of those skills, and I was able to do it. I think as you are talking to folks, young people, people who may be displaced workers and are looking for a second career, and you're talking to them about advanced manufacturing, the thing that we hear time and again from manufacturers that we work with is that it's critical to be a problem solver and an initiative taker. There's a lot, and I think Miguel can probably attest to this on the technology side. There's a lot of things that are going to come up where workers are going to have to think on their feet. And so demonstrating that skill is critical. And we see a lot of manufacturers, especially small manufacturers, struggling to retain workers who are reliable and consistent in showing up to work. And there's a variety of factors related to that. I know in Pittsburgh specifically, our manufacturers tend to be located outside of the public transit lines. And so if you have workers who don't have a car, it's very difficult for them to get there. But if you're talking to a young person who says, I really like working with my hands, I don't want to go to a four-year school, I'm really interested in a community college, getting a degree from a community college in mechatronics or advanced manufacturing or industry 4.0, there's a few different ways that it's talked about, is a great thing to point them into, and they don't necessarily need to have a computer science background.
Great. We have another question from Jonathan. As an organization that's working to provide educational resources to incarcerated learners and future workforce, what do you recommend would be the best way to get individuals prepared for AI and integrating their competencies in a new career?
Yeah, that's a great question. Like we talked about at the beginning of the Q&A session, there aren't really a whole lot of AI like education programs that are available right now. Like I said, I did take a course through Coursera. That was part of my professional development this year to understand AI, because once again, I don't have a technology background. So I think that employers offering those opportunities to their employees, whether it's just providing professional development funds and employees doing it on their own, or I know at the ARM Institute, our IT department put together a short one-day seminar on artificial intelligence. Providing those types of informal learning opportunities is great, because AI can sound really scary when it's like the big AI, and then as you understand it and how it applies to your work, I think that it becomes a little bit more real and a little less scary.
Thank you. That's all the questions we have in the chat. I'm going to give 7 seconds if anybody wants to ask another one. And then I'm going to turn it over to Becky.
Yes.
Thank you so much, Emma and Miguel.
Thank you.
Thank you all. Like Melissa said, I learned a lot every time I talk to you all. So thank you. Well, I just wanted to wrap us up. I wanted to thank you guys for coming today and just tell you a little bit more about what we can do for employers and other groups around the country related to metal. So next slide. As I mentioned, the metal team, we have a lot of partners on the project, and we can do a lot of things for companies, including there's free online training that's available from metalforamerica.org. You can check out those training courses on that website. But the JFF team focuses specifically on development of work-based learning programs, and all of our technical assistance is free, and all it is starts with a phone call. So if anybody wants to talk to us, and it's great if you're an employer, but if you're just an organization working with employers, we're happy to talk to you too. We're hoping you can connect us to those companies. So, we offer guidance about developing a program. We have frameworks for different occupations in casting and forging. We have some of our most in-demand occupations are things that all manufacturers need, are like industrial maintenance technicians. So CNC operators are very important to casting and forging. So it doesn't have to be a very specific casting occupation, but we do offer those things, and we've developed a new outline for forging operators. If you're interested, we love your feedback. So next slide. I do want to mention this. We do have some funding available. If you're a company with an apprenticeship program or in the process of building one or really good work-based learning, we really want to hear from you because we do give out some incentive funding to support those programs. And they can, it's not enough to start a whole new program, but it does help offset the cost. It's $4,000 per person, up to $24,000. And it can be used for all sorts of different things in an apprenticeship, including related training, like an online course, or it can be supplies for apprentices. It could be laptops if they're taking online classes, anything but wages. So all it takes is a little, going on to our online application and filling it out, or you're welcome to just contact our project director, Mark Genoa, or me to have just a conversation first. And you can tell us what you're doing and if you're eligible, and we'll let you know. So I think that's it. Please contact us. We have Lucinda Curry. I'm not sure she's on today, but she is director of the metal project at the Composites. She's at another industry meeting today, but she'd love to talk to you about the metal project in general. And Melissa and I are happy to talk about JFF's work and how we can support you. We love to hear from people. So please reach out, and, thanks again. And if you want, we'll have this recording we can send out to you after it's over. And, you can always reach back out to Emma and Miguel too, if you have questions about their work as well. Thank you, guys. Have a great week.